Okay. So now we'll start to focus in on different kinds of random variables. So we'll have, there are random variables, there are discrete random variables, there are continuous random variables, okay? A lot of situations can be either or, okay? So there are two main types of random variables, discrete or continuous. So we have learned several rules of probability, but only one way of assigning probabilities to events. We assign a probability to every individual outcome. Then we add these probabilities to find the probability of any event. This idea works well if we can find a way to list all the possible outcomes. So we will call random variables having probability assigned in this way discrete random variables, okay? So in other words, it's 1, 2, 3, 4. It's not 1.1, 1.2, okay? It's discrete in the way that discrete always is, right? Weight is not discrete because you can have partial weight. People are discrete. Coin tosses are discrete. Okay, the probability distribution for a discrete random. Here we go. Sorry. For a discrete random variable must have outcome probabilities that are between 0 and 1 and that add up to 1. Okay, so much the same as our basic probabilities. Okay, so the variable x in the coin tossing example that I had in the last video is a discrete random variable. We can list the possible values of x. It could be 0, 1, 2, or 3. I can have 0 heads, 1 head, 2 heads, or 3 heads. 3 tosses. Note that there are gaps between those values on a number line. So the corresponding probabilities are between 0 and 1. Their sum is all 1. That's a discrete. Those are discrete random variables. Okay, so here's another example of a discrete random variable. Okay, so kind of some background. In 1952, Dr. Virginia Apgar suggested 5 criteria for measuring a baby's health at birth: their skin color, their heart rate, their muscle tone, breathing, and their response when stimulated. She developed a 0, 1, 2 scale to rate a newborn on each of the 5 criteria. A baby's Apgar score is the sum of the ratings on each of the 5 scales, which gives a whole number value from 0 to 10. Apgar scores are still used today to evaluate the health of newborns. What Apgar scores are typical? To find out, researchers recorded the Apgar scores of over 2 million newborn babies in a single year. So it's a historical thing here, right? So the idea here is that you're looking at a score, your values being your scores, and then the probabilities are coming from the historical record of these scores based on these 2 million newborn babies in some year. Okay, imagine selecting one of these newborns at random. That's going to be our chance process. We're picking one newborn at random. We're going to define our random variable x as being the Apgar score of a randomly selected baby 1 minute after birth. Okay, so I'm just going to kind of set that up. Oh, what happened? Never mind. Okay, so again, x is going to be our random variable. That's going to be an Apgar score of a randomly selected baby 1 minute after birth. Okay, so the table below shows the probability distribution for x. Okay, so here's the table, and we're going to find a few of these questions, okay? So here are the scores, a score of 0, 1, 2, 3, up to 10, okay? And the probabilities are coming from those 2 million babies. And now we're going to show that this probability distribution for our random variable is legitimate, okay? Well, it's much the same as the last time we did it. We have to make sure that all of these are between 0 and 1, and they are. And we also have to make sure that the sum is equal to 1, and it is. So it would be a legitimate probability. Now we're going to make a histogram of the probability distribution. Okay, so here's what the histogram looks like. And now if we describe what we see. So this is a lot like what we did back in Unit 1, right? We know that it's left skewed. It suggests a random selected newborn will have an APGAR score at the higher end of the scale. There is a small chance of the baby having a score of 5 or lower. Okay. And then finally, doctors decided that APGAR scores of 7 or higher indicate a healthy baby. What's the probability that a randomly selected baby is healthy? Okay. So in other words, we're looking for the probability of our random variable, which is our APGAR score of a randomly selected baby being greater than or equal to 7. Those are our healthy babies. So we're basically going to add these 3 or 4 rather, and we'd have about a 91% chance of randomly choosing a healthy baby. Okay. So now we have to start talking about the means and standard deviation of discrete random variables. Okay, so when we analyzed distributions of quantitative data, like back in Unit 1, we made it a point to discuss their shape, center, and spread. We're going to follow the same strategy with our probability distributions of random variables. You can see what you learned earlier to describe the shape of a probability distribution histogram like we did with those APGAR tests, okay? So then we need to now, if we talked about the shape, we now need to start talking about the center and spread. Here comes the mean and our standard deviation, okay? So the mean of any discrete random variable is an average of the possible outcomes, with each outcome weighted by its probability. So this is an important part. So you'll often hear that to find the mean, we'll often refer to it as the expected value, okay? So we have to take into consideration what the probability of each variable is in order to find the mean. So we're going to multiply each possible value by its probability, and then we're going to add up all of the products like we usually do with our mean. So it's a little bit different, okay? So here's back to that APGAR test, right? So this is a good way of thinking of your expected value, by the way, is your expected value is it's describing a long term, right? A long run averages of outcome. So because not all things are equally likely, it looks a little bit different, right? So let's consider the APGAR scores again. So let's compute the mean of the random variable x and interpret it in context, okay? So what this is, the formula is now saying is that I have to multiply each probability by each APGAR score, okay, in this situation, or each value of your x variable, and then you're going to add them all together, okay? So basically it looks like this. So my expected value is kind of what you expect, right? So what you're anticipating, okay? So you're anticipating an average score of about 8.128, right? And that would kind of signify like exactly what that histogram was saying, which is the idea that a healthy baby, which looks like the vast majority, was over 7. So an interpretation. So the mean APGAR score of a randomly selected newborn is 8.128. This is the long-term average APGAR score of many randomly chosen babies. Note that the expected value does not need to be possible value of x or an integer. So it doesn't have to just be 8. It's okay that even though it's discrete, it can be a decimal there. Okay, so let's talk now about standard deviation. Okay, of course, if you're going to talk about center, you have to understand the spread about your center. Okay, so since we're going to be using our mean here, okay, not our median, so we'll stick with our standard deviation and our variance to understand the spread of our data. Okay, so the definition of the variance of a random variable is similar to the definition of the variance for a set of quantitative data. Okay, that is, the variance is an average of the square deviation of the values. It's a typical variation from the mean, typical distance from the mean. Okay. So to get the standard deviation of a random variable, we're going to take the square root of the variance, which is found using your expected value, right? So you have each value minus your expected value squared times each probability. So we're going to obviously learn a shortcut to this. So it's can be quite tedious, okay? So kind of going through it so that you understand it. So it's each value minus the expected value squared times each probability, okay? So it kind of looks like this drawn out, only not as neat as this, okay? And your standard deviation would be actually your variance would be 2.066. The square root of this would be your standard deviation, 1.437. So the standard deviation of x is 1.437. So what that's saying is, on average, a randomly selected baby's APGAR score will differ from the mean, 8.128, by about 1.4 units. It's the same interpretation of standard deviation that we did with quantitative data. It's the typical variation from the mean. Okay. In class, I'm going to show you how to do this on a calculator, but we'll take care of that when we meet up next class.